Many tough decisions in life are about weighing the cost of doing something today versus the potential benefits of something in the future. This kind of what economists call intertemporal choice is critical in really almost everyone's lives. And the concepts that economists use to think about this choice of things over time has to do with discounted present value. Now, I'll talk about what that means in a few moments, but critical to the idea of looking at choices over time is the use of interest rates. So I want to use a couple of examples of what interest rates mean, and we will use that to build up the idea of present value. So let's say, for example, that you had $100 today, and that $100 could be put into a savings account, and you could get an interest rate of, say, 5% per year. You save it, you don't spend it, stays in the bank, and in a year you get 5% on top of that. Now, the way we think about that is that we take the amount that you invest and you add to it the interest payment, which is $100 multiplied times 0.05. That's 5%. That's the interest payment. So if I take my $100, I can turn that into $100 and $105 after a year. Now, another way to write that is 100 multiplied times 1 plus the interest rate. And that's just kind of the general way of writing what we did up here. This is going to be 100 multiplied times 1, that's the 100, plus the interest rate multiplied times 100. This expression gives us how much that $100 will be worth in a year if we invest it at 5%. Now, let's say I invested it for a second year. Okay, I'm going to get $105, and I'm going to multiply that times 1 plus the interest rate. And after the second year, at earning that same interest rate, I would have $110.25. So I can turn my $100 into $110.25 if I put it into the bank at 5% interest. So here's an alternative question. What if somebody said to you, I will either give you $110.25 in the future, or I'll give you $100 today. This is where you need to weigh the alternative values of something in the future to something today. Now, in this particular example, you should be indifferent between having $100 today or $110.25 in the future, because if you knew that this interest rate was 5%, you could take that $100 today and invest it or save it and get $110.25. And so it'd be the equivalent of getting $110.25 in the future. So when we talk about the general formulation, here's how we do it. Let's say that you invest for 3 years. Okay, I'm going to take my principal, $100 I start with, and I'm going to multiply that times 1 plus the interest rate. That tells me what I get after the first year. Okay, so this would be the 105. I then multiply that times the interest rate for the second year. That gives me the $110.25. And then the third year is 1 plus the interest rate. So what I've done is that I've converted my $100 into some value, some future value, and using this formulation, you should say, I would be indifferent between getting this in the future or having the $100 that I can save and get these interest rates. Now, let me rewrite what I just did. This is equivalent to saying $100 multiplied times 1 plus the interest rate times itself. In other words, 1 plus the interest rate cubed for 3 periods is equal to this future value. Okay? So that tells me the future value of taking my $100 and at this interest rate over 3 periods getting this final outcome. Now let me take that number 100 out and put into it PV, the present value. This is the present value of the payment in the future using the formula that we just did. I can rearrange this to say that the present value is equal to the future value. I'm going to divide both sides by 1 plus the interest rate cubed. That's the formula for present value for 3 periods at this interest rate. So this will tell me what I value this payment in the future when taking into account that there's 3 periods of earning interest. Now, even more generally, if we looked at some arbitrary number of periods, so for, call it T periods, and that could be 1 or 2 or 3 or 10 or whatever years, then the present value of some future value is going to be 1 plus the interest rate multiplied or raised to the t power. Now, when we talked about this with the 3 period, that t was equal to 3. This is what you would put into this formula. Now, this is sometimes written as this formula, 1 over 1 plus interest rate to the t power, is sometimes called the discount rate. So you can plug in the percentages and you can get a specific number, and I would encourage you to do that. So for example, have an interest rate of 5%. If t was, say, 20 years, the discount rate would be 1 0.05 to the 20th power. You can just plug that into a calculator and see the number that you get. And you'll see that the more periods ahead you go, the more period, this gets to be a bigger number. It gets larger and larger and larger. That's another way of saying that I will discount something more, some future value, much more if I get the payment 20 years, 30 years, 40 years down the road. So you have this discount rate, which translates a future value into a current value. Now, another thing to keep in mind is how this discount rate would be affected by changes in the interest rate. The interest rate going up means that I would rather have the money today to earn a bigger interest payment over time. So it will take more future value in order to make me satisfied with that future value. So we'll give an example in another video in just a moment.